So pointers. What are pointers? They are basically variables which store memory address. Now, before we talk about memory addresses, this is basically I'm talking about in terms of programming languages, and C and C++ like they're more prominent in pointers. Other programming languages that might be Java or Python, they also use pointers, but you cannot basically create one. Internally, they are using pointers to basically point to memory, and they are very pointers are a very important topic, and well, not topic. They are very important concept, and it's widely used. For example, some of like blue screen that you get on Windows, some one of the reason for it is have something known as while pointers. That means they are the pointers which are pointing to some random memory locations, and you're not able to detect what exactly the OS is not able to detect what is exactly is happening. So it's a very important concept. It's a very powerful tool being used by the programming languages and the operating system. So let's see what exactly is pointers. So before we, as I said, it's basically a variable which stores a memory location. So that means it is basically telling, okay, this is a memory location. Now, before we understand what exactly is memory location, first of all, when we write any variable like int a is equals to 5. Now this is I'm writing in, this is basically you can say C++ or C, because pointers are mostly used there. Like you can basically define something there as a pointer. So what happens is this particular gets stored in the memory location. So for pictorial representation, this is basically a memory location, and 5 is stored here. A is pointing to this, and this memory address is suppose 100. Now this 100 is not exactly the numeric 100 that we write like 1, 2, 3, 4, 5, 6. No, it is a hexadecimal 100. That's a number, hexadecimal. Like sometimes you get the error like error at 0x00fffe something like that. That's a hexadecimal number. So what I'm going to represent here is the memory location is 100, 100 in hexadecimal. So this is known as R value, and this memory location is known as L value. Now what exactly are these? So coming back to that line again, int a is equals to 5. So pictorial representation 5. This is 0x100. We represent hexadecimal number by starting with 0x. This doesn't formulate the part. It is just to represent, okay, this is a hexadecimal number. So this is R value, and this is L value, and this is basically A. So R value means real value, and L value means location value, where it is stored. R value means what you are storing, and L value means where you are storing it in the computer memory. Real, and L is location. Now pointers, they store these values. They are basically pointing to the memory location. That's why they are known as pointers, because they are telling you, okay, look at this memory location. That's a pointer. It is point why the name itself is coming from, because it is pointing to a memory location. So how do you declare it? Now the thing is, you declare it by using int star p. This star is important. That's how you tell it, okay, it's a pointer. P is, you can use any variable naming, whatever variable, whatever variable you want to use that follows the rules of naming a naming convention of a variable. Well, not exactly convention, rules. Convention is different, and conventions are exactly the standardized format, but rules is basically you need to follow. So this is a simple pointer. I've created a simple pointer variable. Now it is not pointing to any particular memory. So what I can do is, if I want to basically store something, what I can write is p is equals to reference a, ampersand a, ampersand a, ampersand. This is a reference operator. So what it is telling it, when you write like this, it basically give access to this particular memory location. Okay, so now this value gets stored in p. So now you have p, which is storing 100. Okay, again, I'm omitting 0x for now. That's a hexadecimal number. Now, this is as simple as that. Okay, for declaring a pointer. Now, well, coming to this pointer again, what you need to remember is it is not storing 5, it is storing the memory location where 5 is stored. Now, if you want to access, right, if I write P, it will print 100, okay? But if you want to access the value, then star is basically known as dereferencing operator in this scenario. So if I print this one, it will give me 5 because what is the value of P? 100. What it's basically telling what is stored at 100, it is 5. So this is going to print 5. Now another thing to remember is because this variable are storing what memory location, and again it is storing for only, it is going to store only one location because this is because we are not talking about array, we are not talking about pointers, and of course we will talk about that, but this is going to store only one value. Now that value, these numbers can be represented by, again it depends on the compiler. Okay, it totally depends on the compiler which you are using for C++. So whatever is being stored by integer, what is the like value of integer. So some compilers, most of the compilers, they use 2 bytes and some of them use 4 bytes. So pointer is going to store only like the memory space of for one single pointer. For the memory space that will be required for one single pointer is going to be 2 byte because it is storing only the memory address, not any value like uh, float, boolean, or something like that. Okay, it doesn't matter. One thing to remember, it doesn't matter if I have created an integer pointer. I can also create a float pointer, but the memory address used for this p is going to be still going to be 2 or 4 bytes. The number of bytes that is required by the compiler to store an integer, because this particular pointer is not exactly storing the value, the R value, the real value that you have to store, but it is storing the value of the location. And location, that it is basically hexadecimal number, it is not in points, so it is going to remain the same. It is basically the program, it depends on the compiler whether it is going to be 2 bytes or 4 byte, irrespective of what is the data type. Okay, now moving on. So after this, basically now we are going to talk about how do you access these pointers, and we are going to talk, and the most confusion that happens is basically pointer arithmetic. Okay, now first of all, if I write int a is equals to 5, and then I wrote int star p is equals to ampersand a. Okay, so what is going to happen is, as I said, this is basically a, this is storing 5, it has 100, and I'm assuming this number, and then you have a pointer which is basically, suppose this is at, like, suppose 700, and this is p, and this is storing this 100 here. So that is, now you have done it. Now what exactly if you want to do it? So now first of all, you can print a, that will give you 5. If you print p, it will give you 100. If you print ampersand a, it will give you 100, because this variable is going to this operator is going to give you the memory address, and 0x100 for better understanding. If you print star p, that is going to give you 5, because you're telling it, okay, at this address go to this one. Okay, and if you want to get this address, where this where you're storing, because everything is stored in a memory, so you need, where is this particular pointer getting stored, so you have to write ampersand p, that will give you 700. Okay, now this is not required because we are going focusing on pointer arithmetic. Now let's talk about the other one. So what happens is, like, suppose if I write like I'm using this a only, and if I write a is equals to a plus 1, what exactly is happening? I'm just telling it a is equals to 5 plus 1, and then a will become 6. But pointer arithmetic is a bit different because this is a pointer and it is talking about the variable. Like, so what exactly is happening is, when you here we are representing in squares of the memory, but when we talk about, like, suppose our compiler is storing integer in 2 bytes. So when you talk about 2 bytes, that means 8 bits for 1 byte. That means you have 16 bits, right? You have 16 bits. So when we are storing a number, so exactly what exactly is happening is, suppose we are storing, like, suppose a is equals to 5. Okay, so we are storing I'm telling it its starting point as like 100, right? It is, but it is actually using 100 and 101 because it is like this is one byte. So this is occupying both the bytes. So in case of pointer, like suppose if I write like this, and if I write like okay, P is basically pointing to A. Now I tell it if I write, let me clear this up. Now if I write P is equals to P plus 1. What exactly happened is basically suppose now P was what 100, you will say it is 101. Not exactly, because 2 bytes are being used to store an integer, any integer. In our case of compiler, what will happen is this will become P plus 1 into number of bytes used for integer. Okay, in our case it is 2, so this will become P is equals to P plus 1 into 2. So this will become P is equals to P plus 2, and P is what 100. So 100 plus 2, this will become 102. That's why when you're storing it something at like this one, it will move to the next, like and again it is picture representation is basically continuous sequence of memory. Okay, like this is 100, this is 102, 104, 106, 108. And why I'm using I'm using 2 bytes, because as per the compiler it's going to use 2 bytes, so that's why I'm representing this. So that's how pointer arithmetic works. Okay, it is not just simple one addition, you have to basically add that. And again, if you want to reference and you want to get that value, you have to give a star. Now the other thing is we will talk about now arrays. Okay, because we need when you talk about pointers, we need to show why exactly that pointer arithmetic becomes uh, like required, like how this you have to do calculation. So now if I write int a is equals to, and again square bracket, sorry if I'm messing with the declaration because I have, like, it has been a long time I did study C++. So I'm creating an array of 5 elements from 1 2 3 4 5. So now in this will get stored in memory in a sequence of this will get in a sequence. So now if I want to represent this, what I will write is this is A. So this will be 1 2 3 4 5. Now suppose this is stored at 100, this will be 102 because 2 bytes is occupied by this one. This will be 104. This will be 106. This will be 108. Right? So that is how it goes, and it is stored in a sequence. Now, the first thing is if you just print A, if you try to print A, right, it will print not 1 because A is a whole thing that is having a array. So if you just print it, it won't print 1, it will print this one. Okay. What is this? This is known as base address or starting address. Okay. It is known as base address or starting address. Now, how it is used is basically, now here A becomes, A is when if you just focus on A, that is called as base pointer. It is pointing to the starting address of the array. So if you want, and what happened exactly is when you write A at 1, okay. Now again, when I write A at 1 in C++, the numbering, like basically the indexing, right? That starts with 0. So 0, most of the programming languages start with 0. There are some languages that start with 1 and 2, like R and all. So but here it's like 2, 3, and 4. So when I write A at 1, what exactly I'm doing is internally the operation that happens is known as pointer arithmetic. Okay. And again, this is done by the compiler. You're not doing it. So what exactly happens is it takes A, okay, and then what you're telling it, you want to add how much? 1. So you add A plus 1. And again, just using a different method. I'm not changing A. So what exactly happens is A is what? And again, I'm talking about pointer arithmetic. This is using, compiler is using 2 bytes. So what exactly happens is this will get converted into 1 into, sorry, A plus 1 into number of bytes used by compiler, right? So this will become A plus 1 into 2, right? Then P is equals to, now A is what? A is 100, the starting address, the base address. So this becomes 100 plus 1 into 2, that is 2. And this becomes 102. Okay, this is what you got. Now what because this exactly you can, this is basically star of a plus 1. So star of this whole thing. So this is dereferencing. So they're telling, okay, star of 102 memory address. What is that 102? It is 2. So this is going to give you 2. That is pointer arithmetic. Thus, addition, the simple addition is not 1 and 2. It's basically by the number of bytes. Now here in my example, I've taken number of bytes as 2. But if it was like suppose 4, this factor will change to 4 now. So instead of 102, this will come as star of 104. And this whole thing memory address will look like this: 100, 104, 108, 100, 112, 116. So this is how the pointer arithmetic works. Now, what's this? Now you will say that sometimes this also feels complicated. Like when I first learned about it, it was complicated for me also, and it took an effort of a dedicated teacher in my college to teach this. Yeah, and now where it is used, okay? Where it is used, and again, of course, we can. This is for our basic understanding, but it is mostly used. The major use, if I say, it is used in dynamic memory allocation. Now, what exactly is dynamic memory allocation? It is basically a condition in the programming when you want to store some certain value in a variable, but you're not sure how much space it is going to take. Now, this is not an issue with scripting, like modern language, like any scripting language, like Python shell scripting, and also in Java. Like for example, we talk about string. Like in Java, when you want to store a string, you basically import a class and then you add it. You basically create a new object by using new operator, and same thing happens in C++ also. And then you basically create it, and then you can just use it, right? It depends on I can add my name. You can add a very long name like Netaji Subhash Chandra Bose, or my name like small name Abhilash Raj, or like even smaller like AR or something like that. So my pointers are mostly used for dynamic memory allocation. They are primarily used for dynamic memory allocation in which, and again I'm talking strictly in terms of C, because C has something known as malloc, calloc, and realloc. Okay, malloc and calloc, they are both used for creating dynamic memory allocation depending on user input, because they create this reserve memory location at that runtime. Okay, they are not static memory allocation like a equals to 5 or something like that. And realloc is basically if you have a memory location which is getting shorter for you, you can use this to basically reassign. Okay, now the difference between malloc and calloc is malloc, when you use malloc, whatever it's generated, whatever memories are space, they all have garbage value, some random value. Okay, and calloc will have default value which is like null or void, something like that, or zero. I don't remember actually. So that is your pointer. So what exactly happens is you use the pointer. So basically, the simple concept will be you're using the pointer. Okay, you created a pointer. Okay, you created a pointer, and now you're telling it, okay, by using malloc, calloc, or malloc and calloc, what you're telling it, okay, this is my base address. This is how much, like maybe you need to store five variables, six variables, 100 variables, whatever it is. So you're telling it, okay, this is my starting address, whatever this particular function assigns you. And then you're telling it, okay, I need five more. So what exactly happens is base address. So you got a base address 100. Okay, like for other example, let me take like suppose 500. That's the base address. Now you're telling it you need five, you need to store five elements, and this five has come from user input when the program is running. You are not written like okay, in the program itself you are not mentioned that you need five. You're running it is asking you how much you want and how much elements you want to store, so you gave five. So what happens is now you're telling it, okay, how many bytes so what will exactly happen is how many bytes you need? 5 into 2, because our compiler is just 2 bytes, you need 10 bytes. Okay, starting is 500. So how many, and because we are storing it, because we store it this in a when you talk about arrays always get stored in sequence. So what will happen? How much it will take? It will take like 500 is there. Okay. Now you're adding what? You need 5, so 5 into 2. So that is what? 5, 10, right? So 10, so the total is you need till 5, 10. So what exactly will happen? If I, so what exactly will happen here is, so you will have a sequence of memory. Okay. 2, 3, 4. Okay. So this is like 500. This is 502, 504, 506, 508. And keep in mind, it's not, this is the starting address. I'm not saying I'm skipping something. It has a 501 is inside this the other byte. 503 is in here. 500 and so this is like 504 here, 500. So this is a sequence. This is 2 bytes, each of 2 bytes. So that is how pointers work. And of course, these pointers are also used in linked list, trees, graph. They used to basically point to the next node. Okay. So and they basically form the branches in trees, and they help in forming a branch in the tree and then and graph. So that is how pointers work. Let me know if you need any more explanation or any doubts in this.